All right, who's on out here? Anybody got questions for me? Questions, questions, questions. It's just me today. My wife isn't here to moderate, so it'll be a little slow and go on the chat, but we'll make it work. Wow. Nobody on. This may be a really short stream. Go watch Star Wars: The Clone. Just rewatching Star Wars: The Clone Wars. This might be really, really slow, short stream. Where's my Rubik's Cube? Give me something to do. Wife, move my Rubik's Cube. Sure did. There it is. Nobody on. Nobody needs math help. So depressing. This may be a really short stream if nobody has questions. At least one person's on here now. That's always a plus. Any questions? Any questions? Any questions? Wow. No good. Be a short stream. Let's go watch TV. This is so thrilling. There's one solved. Really? No math questions. None whatsoever. Brilliant. I'm not going to sit here forever. So, if I don't have any questions, and by 5:10 I am done. That in the wrong spot. No questions. Wow. I feel like a comedian dying on stage right now. No questions. No questions. I'm not even going to leave this on my YouTube channel. I'm just going to delete it. This is just awesome. Oh, well, let me just look at this calculus book since I'm bored. Let's see what we got. Domain and range of a function, boring. Transformations of a function, boring. Euler, boring. Boring. These are all prerequisites. Fitting, boring. Problem solving. Huh. That's interesting. I haven't worked a problem like this in a while. So I don't want to write on my board. It's all clean. I actually want it to be a real math problem. Any questions? One person. No questions. Super boring. Oh. What's 0 over 0? It's an indeterminate form. We're actually about to do this stuff in Algebra 2, and this is 1.2 in a calculus book. Huh. I'm curious. That's so much easier if you know how to factor it. So much easier. So much easier. it's so much easier. Boring. Oh, good old epsilon delta proofs. No questions. So awesome. So let's see. Good times. No questions? One person? Nobody needs help today. Oh, there's 2 people on here now. Is anybody going to ask me a question? Nobody going to ask me a question? Just going to sit there and watch me look through a calculus book? And we're back down to 1. Woohoo! Oh. No questions. Yay me. We're about to do this also in Algebra 2. The exact same thing. The exact same approach. This is thrilling. 15 minutes and not a single question. This book is not very clear on how to find limits to. No wonder why I was confused on this. Book was not real clear. The area of the regular hexagon described. Huh. That's not even a hard, that's a geometry problem. The difference quotient. Ooh. Wow. They make this look so incredibly complicated to find a derivative with the difference quotient. It is not hard at all. Not hard at all. They make it look so complicated. No questions. Oh. Any questions? I'm about to do just this basic, show you some basic calculus. Book way overcomplicates this. All right. So yeah, let's do this. So I have f of x equals 1 over the square root of x. I'm going to rewrite this as x to the negative 1/2 power using exponent rules, and we'll just use an exponent rules. And it actually asked me to find the limit as delta. I'm not going to use delta x. I'm just going to use h. This book just deliberately made this confusing. As h approaches 0 of f of x, well, that really just simply means I need to find the limit of x to the negative 1/2 power. The general rule says you could plug this in, but this is h, this is an x, blah, blah, blah. Doesn't really matter. But what I can actually do is this. I know that the limit as h approaches 0 of f of x actually equals f of x plus h plus f of x. Should be minus. Should be minus. It's been a while since I've done this. Yeah, it's minus over h. Okay. So I just basically do function stuff here, and I'm going to get, let's see, x plus h to the negative 1/2 minus x to the negative 1/2 over h. All right, so let's see. This really means I have 1 over the square root of x plus h minus 1 over the square root of x over h. Easy enough. This gives me the square root of x minus the square root of x plus h all over the square root of x times the square root of x plus h all over h. Yeah, it's easy enough. This gives me the square root of x minus the square root of x plus h over, let's see, the square root of x squared plus xh all over h. So I've got to multiply this by, should be the conjugate. So I'll multiply this by the square root of x squared minus xh over the square root of x squared minus xh. So I'm just multiplying it by 1. This gives me the square root of x minus the square root of x minus h times the square root of x squared minus hx. This should give me x to the 4th. The middle terms cancel out. Minus, oh, this is one of those stupid rules. Minus x squared h squared. That's the square root of. Boy, this is just nasty. All over h. And this is why you don't do the difference quotient, because this derivative is just negative 1/2 x. I subtract 1 to a negative 3/2, and I'm done. That's the actual answer that I get. Keep going with this. This just gets nasty. I don't want to do this anymore. I don't want to deal with this anymore because of this square root in the bottom. I'm being lazy. Anybody got math questions for me? Any actual math questions for me? Oh, can you do parallelogram day 1, question 2A? Yeah, sure, I can do that. Talking about this week's the parallelogram test. Okay, cool. All right, so you said 2A. So 2A, it says determine if by doing test 1. Test 1 says all sides have to be parallel. So I have point A, which is -6, -3. I have point B, which is 2, -3. I have point C, which is 4, 4. And then I have point D, which is -4, 4. All right. So the first thing I do with these is I need to, I'm going to sketch this out to actually see what are the sides, and I'm not accidentally using diagonals. So I'm going to just do a generic sketch here. -6, -3. This would be A. 2, -3. This will be B. C will be 2, so 4, 4 up here would be C. And then -4, 4, this would be D. Okay. So it kind of looks like it's a parallelogram test. It tells us to use test 1. That basically says that if the opposite sides are parallel, then it's a parallelogram. So what we need to see is we need to see if the slope of AD is equal to the slope of BC, because these are the opposite sides. AD, BC, they're the opposite sides. And the same thing, if we know that the slope of AB, so AB here, it would have to equal the slope of DC. If these are true, if these two statements are true, then it's a parallelogram, and that's what I was asking you to do on this problem. So we need to use our slope formula. Our slope formula is the y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is how I'm going to find my slope. So we're just going to find the slope of each of these. Slope of AD. All right, so slope of AD. So we need to do y sub 2 minus y sub 1. So 4 minus a negative 3. 4 minus a negative 3 over negative 4 minus a negative 6. So negative 4 minus a negative 6. This becomes 4 plus 3 gives me 7. This becomes negative 4 plus 6, which gives me 2. So the slope of AD is 7 over 2, providing I did everything right. All right, so now we have the slope of BC. Now the slope of AD and BC right here, if they're equal, I can keep going. If they're not equal, I can stop, because at that point I know it's not a parallelogram. So let's look. BC. So we'll do 4 minus a negative 3. 4 minus a negative 3. Hey, that looks okay. And then we're doing BC. So 4 minus 2. 4 minus 2. 4 minus a negative 3 is 7. 4 minus 2 is 2. These have the same slope, so this is good. That one's right. So we know that AD and BC are parallel. Now we need to check the other sides. So we'll do the slope of, let's do AB. The slope of AB, let's see, is going to be negative 3 minus a negative 3. So negative 3 minus a negative 3 over. And then let's see, we're doing AB. So 2 minus a negative 6. 2 minus a negative 6. The top is 0. The bottom is 8, which gives me 0. So that means if DC's slope is 0, it's a parallelogram. If it's not, then it's not a parallelogram. Now we're just going to do the slope of DC. So DC. So 4 minus 4. 4 minus 4 over negative 4 minus 4. So negative 4 minus 4. This gives me 0 over negative 8, which gives me 0. Now, because the slope of AD, so we know these two segments are also parallel. Because we know that slope AD and BC are parallel, and slope AD equals the slope of BC, and the slope of AB equals the slope of DC. Since that's a true statement, that makes quadrilateral ABCD a parallelogram by that first test on that paper, where it says that all the opposite sides have to be parallel. So that's what you're going to do for B and C, is just kind of do the same thing. Just it's practice doing the slope, really is what it's doing. Hopefully that helps you out. What other questions? Coda, what you doing? Come here. Coda. Coda. Coda, come here. I don't have the Coda cam turned on. Come here. Coda. Come here. Come on. You want to say hi to your fans? You got sticker burrs all over you, buddy. I probably shouldn't do that, because then you're going to start whining. Any other questions? What do you mean by work, Spencer? How can I get some geometry work? You go into Schoology? Go into Schoology, it has the geometry work in there. Yeah, if you just go into your Schoology folders, the geometry work will be in there. If you want extra work, I can send you extra work. I don't have a problem with that. But then you would just have to message me on Schoology, and I would send it to you individually if you want more work. What else? Code is ready to answer questions. See, he's bored. Oh, wait, we're up to 3 now. Went from absolutely being totally boring to now 3 people on here, Coda. You're famous. What are you doing? Look, you're good. You're not going anywhere. He looks so mad. You want to take pictures with the green screen this weekend? Wow. He looks so mad. You can tell he just woke up. Any more math questions? You want down, buddy? There you go. On week 2, day 3, question 5, you have us do a reflection over the y-axis. Well, when I use the graph to do the reflection, I get a different answer than when I do. What do you mean by you get a different answer? That's algebra. Let me find it. Right here. So on 5, I have you do a reflection. Nope, not this one. Right here. Yeah. I got you on geometry. So on 5, you do a reflection over the y-axis. When I use a graph to do the reflection, I get a different answer than when you do. What do you mean by that? What type of graph are you using? Are you using a program like GeoGebra or anything like that? Because I can tell you why you could be getting different answers. Because you have to do these in exact order, the order that I wrote them in. If you don't do them in that order, you will get a different answer. No, a paper graph. I would go with the math. More than likely, your algebra, the math part isn't wrong. I can work this one for you and go through the 5 steps if you want and see if you match up with the answers I get. Would you want me to do that? So here's what I'll do. I want to do 1 point. Yeah, I'm going to do one of the points, and then you'll see if you did it the same way I did or if there was something slightly different. So we have an order we have to do things in. So we're going to do, the first thing I'm going to do is I'm going to do point E. So let me write what I need to do. I'm going to do a vertical. I'm going to just abbreviate it. Vertical up 14. Well, this is my x plus 14. Vertical up. Well, vertical is your y. I don't know why I wrote x, y. And then my x stays the same. So there's my mapping. And then I'm going to do point E. So point E is 2, 4. And this is going to give me my E prime by just plugging this in. I get 2, 18. Just take this 4, plug it in here. 4 plus 14 gives me 18. The second step I have to do is I need to rotate 180 degrees. It doesn't matter clockwise or counterclockwise because it's the exact same mapping. And the rotation of 180 degrees should be negative x, negative y. Let me double check. Yeah. So what I'm going to do is I'm going to take my E prime, which is 218, and when I map it to my rotation of 180 degrees, which is negative x, negative y, which now gives me E prime prime. That means I just changed the sign on these at -2, -18. All right. So the third thing I have to do, it says reflect over the y-axis. So this is where you have that question. Reflect over y-axis. So we're going to use e prime prime, which is -2, -18, and that's going to map, from what you were saying, it is -xy, and reflection over the y-axis is -xy. So you're right on that. And that's going to go to e prime prime prime, which now means I'm going to negate my -2, so it becomes 2 -18, because the y stay the same. And then 4, I have you go down, vertical, down 14. So I'm going to do e prime prime prime, which is 2 -18, and that's going to map to, let's see, vertical is my y, down is -14, and of course I have my x right here in front. This is going to give me my e prime 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 prime. So my x stays the same, and I got -18 minus 14 should give me a -28, -32. And the last thing I want you to do, number 5, is a reflection over the x-axis. So reflect over x-axis. All right, that's not very bright. There, that helps. All right, and then from there, the reflection over the x-axis should be -yx, or x -y. Yeah. Reflection over it is x -y. So I'm going to do e 1, 2, 3, 4, which is 2 -32. That's going to reflect to -x, nope, x -y. And that's going to give me e 1, 2, 3, 4, 5. So my x stays the same at 2, and now I just changed the sign to 32, and I'm done. That's what I get. That right there is what I get when I go through all 5 of those steps. Tell you what, let me graph it on. Perfect. If that's what you got, then I'm going to roll with it, because those are the mappings, and I tell you the specific order you do it in. So you may have done it. You may have done them in the wrong order or something along those lines. It's really hard to keep a track when you're actually physically graphing these. It's much easier just kind of list it out like this. What other questions? What else? What else? What else? That drink's done. Oh, man. I don't know about y'all, but I've been going stir crazy here. At least I got to do some work, actually work from home, so I got to do something to have some human contact, at least over the phone at least. I can only watch so much TV. Oh, there's another person. Any math questions? Me be bored. Got a whole nother month of this. Can you help with a pre-calculus packet? Sure can, Garen. How'd you get your hands on a pre-calculus packet, or is it a friend of yours? Let me pull up and see if I have access to it. But yeah, I can help it. I can help with pre-calculus for sure. Yeah, what do they need? I taught pre-cal for 5 years, so I know pre-cal pretty well. Hopefully they put all 3 weeks in pre-calculus. I just have 2 weeks. So yeah, they can ask me the question, Garen. Week 2, day 1, practice number 4. That works for me. Week 2, I don't have week 3. I'd have to email Mr. Laver to get that actual packet, the paper packet of it. Week 2, day 1. Week 2, day 1, practice number 4. Evaluate the trigonometric function. That's 2, day 1. Third? Is it this? Arc cosine of root 2 over 2 equals pi over 4. Is that what they're asking? Is that the question they're asking about? Day 1, week 2, practice number 4. Because there's 2 number 4s on here. Is it this one or is it arc cosine of negative root 3 over 2? Which one is it? I'm changing markers. I think this marker is dying. Which one is it, Garen? Inverse cosine. Okay, so this one. Okay, cool. All right, this is actually pretty easy. So we want to know, oh yeah, that looks so much better. Arc cosine of negative root 3 over 2. Okay, so with this, to evaluate this, you should know your unit circle. So I'm going to have a unit circle over here. And arc cosine, you have to think of all students take calculus. And this tells us where everything's positive. If we know where everything's positive, we also know where everything's negative. And we also have to know the domain restrictions of cosine. Well, the domain restrictions for cosine is from 0 to pi. So my arc cosine can only be in these 2 quadrants right here. That's it. So from there, I can actually find this answer. So I can't have an answer in quadrants 3 or quadrants 4, and I'm not going to get a negative answer with the arc cosine. We just need to know at what point is cosine negative square root of 3 over 2 and find that angle. Well, let's look at quadrant 1, and then from there we can mirror everything out. So here's 30 degrees, 45, 60. This is 0, 0. Nope. 1, 0. Wow. This is square root 3 over 2, 1/2. This is square root of 2 over 2, square root of 2 over 2. This is going to be 1/2, square root of 3 over 2, and then this is going to be 1, 0. Now we're going to come over here and do these quadrants, which are actually just mirrors. It's just a reflection. So this is going to be, so we're skipping 30. This is 90, so this is 120. So this is going to be a negative 1/2 root 3 over 2. We can jump all the way down. Let's see, this is 120, this is 135. Negative root 2 over 2, root 2 over 2. And then this would be negative root 3 over 2 and 1/2. And this is 150 degrees. Okay, so cosine is your x value. So we're looking for we're looking for an x value in quadrant 1 or quadrant 2 that has a value of negative root 3 over 2. Well, that's right here at 150 degrees. So arc cosine of negative root 3 over 2
is 150 degrees. Now, if they want it in radians, you would have to know what this radian is. Well, that's pretty easy because 30 degrees is pi over 6. This is going to be 1 minus the denominator, so this would be 5 pi over 6. So both of those would be your answer. Pretty straightforward question. Justin. Huh. Hopefully that kind of helps you out. It's a pretty easy, pretty basic. This is just a unit circle question. Is basically saying instead of cosine, because if I would have asked you what is cosine of 5 pi over 6, you go to 5 pi over 6, which is here, and you look at the x value, and that would be negative root 3 over 2. So it's just a different way. Instead I tell you I have an x value of negative root 3 over 2. What's the angle? That's all the arcs are doing on the unit circle. What else? What else? What else? What else? Can you do day 2, question 1a for parallelograms? Yeah, sure. Let me erase and I will get that done for you. Walk you through it. Okay, so this current week, day 2, 1a. Oh, okay. This is actually pretty straightforward again. All right, so we're still testing for parallelograms, but now we're doing a different test, and that's what I'm actually having you do on 1a and 1b. So if you look at a and b, one says midpoint formula, one says distance and slope. So those are the tests I actually want you to use to test. So we have point A, which is -6, -3. We have B, which is 2, -3. C, which is 4, 4. And D, which is -4, 4. Pretty sure we just did use these points, but we're going to do a different test to show it's a parallelogram. So once again, just kind of trace it out. -6, -3, that's A. 2, -3, this is B. 4, 4, this is C, and then this is D. So we trace it out, and it kind of looks the same. Now with the midpoint I actually just learned this test this year, which actually makes parallelogram tests so much easier. You have diagonals here, and they bisect each other. It doesn't mean that this A to this middle point is going to be the same length as D to this middle point. But what it does mean is the D to this middle point and this middle point to B, they're going to be congruent. So what happens is when they bisect each other, the only way that happens is they have the same midpoint. So if we use our midpoint formula, which is x sub 2 plus x sub 1 divided by 2 and y sub 2 plus y sub 1 divided by 2, if my diagonals have the exact same midpoint, this is a parallelogram. It's that simple. So in this case, I need to find the midpoint of AC. And if that equals the midpoint of DB, then it's a parallelogram. That's it. So those are segments to be actually accurate. All right, but if they have the same midpoint, it's a parallelogram. Boom, you're good. If they don't have the same midpoint, not a parallelogram. So let's find the midpoint of AC. So let's do mid AC. All right, so this tells me I need to take the average of my x's, average of my y's. So I'm doing A and C. So I have -6 plus 4 divided by 2 and -3 plus 4 divided by 2. It doesn't matter what order you do it in because addition is commutative and associative, so it doesn't really matter. So this gives me, let's see, that gives me -2 over 2, -2 over 2, and this gives me 1 over 2, which then reduces down to -1 over 1/2. All right, so there's the midpoint of AC. If the midpoint of DB is -1, 1/2, it's a parallelogram. Done. That easy. So we're going to do the midpoint of dB. So let's look. So we got, wow, my finger itches. I don't know why. That's weird. We're going to do -4 plus 2. So we got -4 plus 2 divided by 2. And my y's are 4 plus a -3. 4 plus a -3 over 2. Well, -4 plus 2 gives me a -2 over 2. Hey, that looks right. And 4 minus 3 gives me 1 over 2, which now gives me a -1/2. Wow, I can't write today. Trying to run off the board. This gives me -1 and 1/2. Because these have the exact same midpoint, we can say a quadrilateral ABCD is a parallelogram because the diagonals bisect each other, meaning they have the same midpoint. Pretty straightforward. I actually like this test. That's the easiest one to do. Number 10, not possible. Let me look at it and see. Let me erase this and I'll look and see if number 10 is possible. All right, let's look. Number 10. Arc cosine of -3 over 2. Okay. So arc cosine of -3 over 2. Let's see. If you just put it in the calculator, I bet you get an error. So just from my remember, cosine is bounded, so cosine theta, the range of this is going to be -1, -1 and 1. So if the domain of this is the inverse, my range, no, this is the range, so that means this the domain. The reason why is because it's outside the domain. Your domain here, you can only get at numbers from -1 and 1. So since -3/2 is -1.5, it's outside of my domain, so this does not exist. It can't be done. That's just a quick check to see if you know what the domain inputs are. You have to have numbers between -1 and 1, and that's it. You can't do anything else besides that. So if you get -1.5, even if this was -1.000001, it doesn't matter. Can you do Algebra 2, Week 3, Day 2, Numbers 1 and 3? We are going to continue sine, cosine, and tangent in geometry. At this point, because we've talked, Mr. Fitzgerald, Mr. Shotwell, and myself, we're going to do, if we have time, law of sine, law of cosine, but not much on sine, cosine, and tangent. Just because you guys really struggle with that one, and try to do that from a distance would be really difficult, or geometry. All right, let me look at the Algebra 2. That was last week, right here. We are, let's see, Algebra 2, Week 3, Day 2. Number 1 and 3. Well, I'll let you pick. I'm not going to do both of them, but I will let you pick and tell me which one you want me to do, number 1 or number 3. I have a feeling you're going to pick number 1. What do you think, Jay? 1 or 3? Number 1. I already knew that. All right, so I want you to basically add these rational functions and give me the domain. I have x plus 3 over x squared minus 2x minus 8 plus x minus 5 over x squared minus 12x plus 32. Okay, First and foremost, anything with rational functions, factor, 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 and then factor some more. Get it completely factored. So my top's already factored to x plus 3. Can't simplify that. Let's see. This bottom part is going to factor to x minus 4, x plus 2. That gives me negative 4 times 2 is negative 8. Negative 4 plus 2 gives me negative 2. There we go. My top is factored here, x minus 5. Let's see, 32, that's going to be 6 and 6. That's going to be x minus 6, x minus 6. Did I really do that to y'all? No, because 6 and 6 is 36, not 32. What am I thinking? That's 8 and 4. Wow, factored that wrong. This is x minus 4, x minus 8, negative 4, negative 8 is negative 12, negative 4 and negative 8 gives me a positive 32. Now I'm factored. All right, now to add these, we have to have a common denominator. Common denominators, with numbers, not terribly hard to figure out, but with these rational functions, you've got to be able to factor it first and foremost. So once it's factored, I can actually see what are the prime factors of each rational function. I can see this first one has an x minus 4 and an x plus 2 in the denominator. I see this one has an x minus 4 and an x minus 8 in the denominator. What I need to do is I need to make sure the denominators match up. What I'm going to do is I'm going to multiply by the number 1, because if I multiply by 1, it doesn't change the equation at all. But there's an infinite amount of ways I can write 1. So I'm going to look here, and I have an x minus 4, x plus 2. And I've got an x minus 4 and an x minus 8. Well, this one doesn't have an x minus 8. If I get an x minus 8 here, I would have 3 terms, and this is going to work. So I'm going to multiply this by 1, which is going to be x minus 8 times x minus 8. Over here, I'm going to look at this denominator, x minus 4 and x minus 8. What is it actually missing? It's missing the x plus 2, so I'm going to multiply by 1. I'm going to do x plus 2 over x plus 2. All right, so now I'm going to multiply straight across, and I'm going to get x minus 8 times x plus 3 over x minus 8, x minus 4, x plus 2. Plus, I now have my x minus 5, my x plus 2, all over x minus 4, x minus 8, and x plus 2. Okay, so at this point, my denominators are common. It doesn't matter they're not written in the same order, because multiplication is commutative. You're allowed to write it in any order and still get the same answer. So I have my common denominator, so now I do add up my top part. So I'm going to distribute. I'm going to get x squared minus 5x minus 8, 16, 24. So that's just this distributed. Plus, this gives me x squared minus 3x minus 10. That's the second part. So this x squared minus 5x minus 24 is when I do distribution or box on this, FOIL or box. I do FOIL or box here and I get x squared minus 3x minus 10. And that is still all over my least common denominator. I'm being lazy. Least common denominator, this whole thing right here. From here, I just combine like terms. I have x squared plus x squared. I've got 2x squared. I have a negative 5x plus a negative 3x. I got a negative 8x. And then I've got a negative 24 plus a negative 10, which gives me a negative 34, all over the x minus 8, x minus 4, and x plus 2. Now, depending on your teacher, they may want you to expand the bottom. I don't care if my students have to, because I'm just really looking, can they actually combine everything correctly? I don't care. They can mess this up. But I still need to look for the domain. The domain means I'm going to basically take my denominator and set each of these individual terms not equal to 0. So I do x minus 8 cannot equal 0. I do x minus 4 cannot equal 0. And x plus 2 cannot equal 0. And you just solve. And that's going to give me that x cannot equal 8, 4, and negative 2. So the domain of this, my domain is going to be the set of all x's such that x is an element of the real numbers and x cannot equal, let's see, let's put these in the smallest to largest, negative 2, 4, and 8. And done. So that's the domain and how to actually do this. Not horrible. Not horrible at all. Any more questions? So yeah, the rest of them are like that. Number 3 that you're asking, the bottom part of the first one, it actually factors as the difference of squares. So that one shouldn't be terribly bad. It's very similar to this. Just ask yourself, what do I need to put in that what should my least common denominator be? Which is basically all non-repeated factors. What else? What else? Any pre-cal questions? Pre-cal, Algebra 2. I'm gonna probably shoot Mr. Laver a text and ask him to email the work over to me for pre-cal, so I have that. I don't think I'm gonna get many. Or I might just go to the high school and pick it up tomorrow. That's probably what I'll do. Probably just go to the high school and pick it up. What other questions, guys? If you got more questions, I'll answer. If not, I'm gonna kill the stream. Questions? Oh, good times. At least I gotta do some basic pre-cal. What else do they have y'all do in the second week? Rectangle, day 3, question 2. Yeah, pre-cal's pre-calculus there, buddy. Rectangles, day 3, question 2. All right. So which one do you want me to do, A, B, or C? Because these are just kind of critical thinking questions. I don't want to work the whole problem for you, but I'll show you one of these, how to critically think your way through it. A, B, or C? I would say C. C looks fun. Oh, you want to do A? All right, we'll do A. I'm going to do C also because C looks fun. Screw it, I might as well do B too. All right, we'll do the whole thing. Who cares? All right, so I have a rectangle. Whee! And it's got diagonals drawn in. Okay, C. I'm going to do all 3. Who cares? Let's see. This is J, K, this is M, N, and Q, and A. So let's do A. A tells me NQ equals 2x plus 3. Then it tells me QM equals 5x minus 9. And it's looking for JQ. That's what I'm looking for. All right. So let's see what we've got. We've got NQ. This is if it was a circle, we'd call it a radius. It's just going from the corner to the center. And then we have MQ. MQ, it's doing the same thing. Well, what's really nice is that my diagonals, when they bisect each other, they form congruent segments. So NQ is congruent to QM, which is also congruent to JQ. So if I know this length, I know all these lengths right here. So congruent leads to an equal sign. So we just set these equal to each other. So we're going to get 2x plus 3 equals 5x minus 9. We're going to solve, subtract 5x and subtract 3 from both sides. Get all my x's on one side, all my constants on the other. And I'm going to get negative 3x equals negative 12. Divide by negative 3. And then x equals 4. Now, that's what x equals. To find the length, I just plug it back in. So I can actually say JQ is going to be 2 times 4 plus 3, which gives me 8 plus 3, which gives me 11. And voila, there's A. A's not bad. All right, so B. B is kind of the same thing. JQ, slightly different. So JQ, I tell you JQ is x plus 5. So JQ, half of it is x plus 5. And I say NK, now you have to pay attention to what I'm giving you, 3x plus 7. So NK, I give you the whole length. And I'm asking for QM. So I'm asking for a QM. So I'm asking you for half of it. All right, so now what do I do here? Well, if all these are the same, I have NK. I could divide this by 2, but ooh, I got fractions. But JQ, I can multiply this by 2, and I can get JM. And I know that JM is going to be the same as NK, and I can set those equal. So I can do 2 times x plus 5 equals 3x plus 7. We're going to distribute. We get 2x plus 10 equals 3x minus 7. Let's add 7 to both sides and subtract 2x from both sides. And I'm going to get 17 equals x. And that's going to be for the whole length. So keep that in mind. So now if I know x is 17 and I know JQ is congruent to QM, all I have to do is do QM equals 17 plus 5, which should give me 22. So that's B. So not terribly bad. So I'm going to erase and I will do C. I think that's thunder out there. All right, and then C. So C on this problem, I tell you the measure of angle NKM equals x squared plus 3. And I tell you the measure of angle. So if there is an x in the middle of the rectangle is congruent. What do you mean by that? If there's an x, you're talking about the diagonals like this? Because what that means is that these legs, these parts are all congruent. So if it's a rectangle, we know that these are all congruent, and that they're all going to bisect each other. Yeah. So NQ, JQ, QK, and MK, QM, they're all the same. They're all congruent. Well, if this was 1 and this is 1, we add them, that's 2. If that means that this has to be 1 and this has to be 1, that makes that 2. So that means these whole lengths right here are also congruent. So there's different ways you can actually ask these questions. All right. And then the measure of KNN, that's an N, M equals 15 minus X. And I asked to find X. Okay, so I'm asking to find X. So let's look. So NKM. So this angle right here. And the measure of K and M. K and M. This angle right here. Wonder why I did that. Probably because these are parallel. This is a transversal, and we know same side interior angles are supplementary. So supplementary means they equal 180 degrees. So I just simply do x squared plus 3 plus 15 minus x equals 180. I add them up, they have to equal 180 because they're same side interior, same side interior angles. From here, we're going to combine anything that we can combine. We're going to get x squared minus x plus 18 equals 180. 2936. Oh wait, we're going to subtract 180 from both sides, because from algebra 1 you should have learned how to solve a quadratic. X squared minus x, and this gives me 162 equals 0. Yeah, negative 162. So we have to find the factors of negative 162. Easy enough. We just do 162. 1, 2. Now, you know what? I'm just going to jump right to the quadratic formula. I don't feel like factoring this. I'm going to jump right to the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. You should remember that from algebra 1. All right, Garen, I'll get to the pre-cal problem here in a second, okay? So let's plug this in. I've got, let's see, negative b, so it's going to be 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 162 all over 2. We just throw that in. 1 plus, this becomes 1 plus or minus the square root of 4 times 162 is a big number. 4 times 162, 648 over 2, which gives me 1 plus or minus, that's square root of 649. I really make a mistake. I really did this to y'all, which gives me 25.48 over 2. And then from here, you just finish it out. You got 1 plus 25.48 divided by 2 and 1 minus 25.48 divided by 2. And those are your two answers. Easy enough. You can only use the positive one because it represents a distance. All right, so let me do the pre-cal one then for you. I could have swore that worked out. I wonder if I made a mistake in my math. Did I write it down right? Probably. I may have typed it wrong. That was not my intent to give you a decimal. I meant to give you a perfect number. But that happens when you make problems. Sometimes you make little mistakes. You can still do the math on it though. No big deal. Okay. So week 2, day 2, number 8. You're talking pre-cal. So week 2, day 2. How did they do this? I didn't even know you were down there, Coda. Week 2, day 2. Week 2, day 2. Number 8. Oh, I love these. Who the heck typed this? All right, so we have tangent of arctangent. I'm just writing it this way. I don't feel like actually writing out arctangent of -5 equals -5. So what exactly are they having you do on this? Okay, so that's easy enough. First thing I need to figure out is what quadrant to draw my reference triangle in. So I'm looking at arctangent being negative. That means I want to look in quadrant 4. I'm going to look in quadrant 4. Tangent being negative. So all students take calculus. Tangent is negative in quadrants 2 and 4. Arctangent being negative is cast. So it's right here. So I'm going to draw my reference triangle in quadrant 4. All right. So this is my angle, theta. So arctangent, this is giving me my setup. So arctangent, so tangent is y over x. So my y value has got to be -5. My x value is 1 because this is -5 over 1. That still gives me my -5. And now it just simply asks me for tangent of this triangle. Tangent theta. Well, tangent is opposite over adjacent, gives me -5. I don't understand what they're asking with this question. What are they asking? Oppositions, yes, yes, yes. They just want you to throw this in a calculator? Because this is how I solve it, but they give you the answer. This is the setup. You just throw it in the calculator, you get an answer. They want to know theta. I mean, I don't even know what they're asking on this, to be honest with you. Are they just asking if these are possible or not possible? That's weird. I don't even know what they're asking. It's definitely possible because you have to verify that. This is your verification right here. Oh, let me turn my speaker off. It's about to die. This would be your verification. It didn't say verify. There's not even instructions on here. I'm not sure. Yeah, I mean, to verify it, this would be your verification right here. You would have to say something like that tangent is, or arctangent is negative in quadrant 4. Yeah, I'm not sure either. Message your teacher and ask them specifically what they're asking for, because there's not actually telling you what they're looking for. Because they give you something, I mean, this is a true-false statement. This is true. I mean, this is a true statement. If you needed to verify it, I would verify it this way. Because I know tangent being negative has to be in quadrants 2 and 4, and arctangent is negative in quadrant 4, so I draw my reference triangle in quadrant 4, my reference angle. Can you help me with the first practice problem? Yeah, we can do that. We can do this. So they want to know arcsine of sine of 3 pi. Okay, that's easy enough. First thing I want to do is I'm going to throw out, I don't know if they've talked about coterminal angles, but sine is sine is a cyclic function, so it repeats every 2 pi. So this is going to be the exact same answer as arcsine of sine of pi, because I just do 2 pi minus 3 pi and I get pi. Well, sine of pi is on the unit circle. This now, sine of pi, this equals 0. So now I have arcsine of 0. Arcsine of 0, well, that's actually going to be at 0 radians or 0 degrees. Because it's with it, because arcsine has to be between negative pi over 2 and pi over 2, or negative 90 degrees and 90 degrees. That's it. I don't know if they talked about coterminal angles, but if anything is greater than or less than 2 pi, you can either add or subtract 2 pi to get to an angle between 0 and 2 pi, or 0 and 360. If it's, of course, if this is in degrees, this is in radians with pi, but if they would have told me that this was, what is that in degrees? That's 360 plus 180, 540 degrees. I would just subtract 360, it would have done the same trick. Not terribly bad. That's kind of how you do most of these. What else? That one's not terribly bad. They talk to you guys about using coterminal angles to reduce your angles to simplify your problem? Number 4. Easy enough. All right, so we have cosine of arcsine of 5 over 13, and they want to know the answer. Okay, so the key to this is setting up your triangle correctly. So we have to know, I taught my kids cast. And what this is 0, this is pi over 2, this is pi, this is negative pi over 2. This gives you where you're going to set things up. Because cosine, if cosine is negative, you're going to set it up in quadrant 2. If arc cosine is negative, you set it in quadrant 2. If anything, if they're always positive, you're going to be in quadrant 1. And if sine and tangent are negative, you would set it up in quadrant 4. Well, arcsine here, it's just positive, so that means I'm going to draw my reference triangle in quadrant 1. So here's my reference triangle. Here's my reference angle right there. It's always, the reference triangles always have their point right here at the origin, and your reference angle is what's from the line up to your hypotenuse. Now sine, if you know, sine is opposite over hypotenuse. Well, my opposite here is going to be 5. My hypotenuse is 13. But I need cosine, because cosine, these are thetas, is adjacent over hypotenuse. Well, this is just nothing more than the Pythagorean theorem. I could do the square root of 13 squared minus 5 squared, which gives me the square root of 169 minus 25, which should be the square root of 144. Yep. And the square root of 144 is nothing more than 12. So this length is 12. It's a basic 5, 12, 13 Pythagorean triple. So now I can actually say cosine of theta, cosine of this angle is going to be my adjacent, which is 12 over 13, and I'm done. So the answer here would be 12 over 13. Easy enough. Key is the setup. The setup, the setup, the setup. With these problems, you have to be able to set it up correctly. What other questions? Who's your teacher? Is it Mr. Laver, Miss Dennis, Rogers, Coach Rogers? Just kind of curious to let him know I was helping somebody. 9 and 10. Your choice. Dealer's choice. I'll do only one of the two. I'm not going to do both of them. I like 9. You want to do 9? Let's do 9. Oh, you got the Laver. You want to do 9 or 10? I don't care. 9 looks fun. 10 looks fun too. Nine. All right, works for me. So we're going to do secant of arcsine of x minus 1. All right, same thing here. Does he tell you what quadrant it's in? He does not. He does not tell you if x is positive or negative. That's interesting. All right, I'll have to yell at him about that. We're going to assume that this is going to be a positive number. Well, right off the bat, we're going to assume it's a positive number to solve this problem. So we're going to, everything positives in quadrant 1. Here's my theta. We know that sine of my theta is my opposite or my y over my radius, y over radius. Does it find the exact value? Well, I'll give you the exact value. It's okay. We're good. So y over x. So I know that this is my x minus 1. My radius is 1 because this is just over 1. This is nothing more than, you ready for this? Ready? Pythagorean theorem. So to find this, we're going to do 1 squared minus x minus 1 squared. We're going to take the square root of it. Well, 1 squared is just 1. This becomes x squared minus 2x plus 1. We're going to take the square root of that. We're going to get the square root, and this is plus or minus, which will actually take care of either quadrant. We're going to combine like terms. I've got negative x, oops, I do it this way. I was about to drop a sign and make a mistake. So I have 1 minus x squared plus 2x minus 1 because I have to distribute this minus. Well, 1 minus 1 is just 0. So this gives me plus or minus the square root of negative x squared. Negative x squared plus 2x. Okay, so that's this right here. So we're going to assume it's positive, so it's going to be the square root of negative x squared plus 2x. All right, so now I have all three sides of my triangle, and I want secant. Secant of theta. Well, secant is the reciprocal of cosine. If cosine is x over y, x over r, this is going to be r over x. Wow, he really did this to you. So your secant is going to be 1 over, because that's the radius, the square root of negative x squared plus 2x. Done. That's easy enough. That's my exact answer. Technically, you should have a plus or minus right there. Can't really get a numerical answer out of this. This is the way it's set up. So that's the answer. I don't know if he wants you to rationalize the denominator. I'm not going to, because that's just nasty to rationalize that. Oh. Tad. What else? Yeah, good luck with that one. I would never make my kids rationalize that. Because that is way more complicated than what y'all are used to. That is way more complicated than what y'all are used to. I mean, you could rationalize it, but it's just going to be nasty. I'd leave it with that and ask if you want, and just maybe say, hey, I've got this answer. Do you want me to rationalize the denominator? It's pretty nasty. Now, could you go over the practice problems of day 2? For what class, Justin? The sketch of number 10? Yeah. The sketch of number 10, arc tangent, we're going to assume to be positive. Tangent is y over x. So when I look at it, I have my x is x. My y is root 2. And then Pythagorean Theorem, your hypotenuse is going to be the square root of x squared plus the square root of 2 squared, and then go from there. So this ends up being the square root of x squared plus 4. And then just answer your question from there. That's pretty straightforward. Okay, so you want to do, could you go over the practice problems of day 2? That's what I'm doing right now, is the practice problems of day 2. Are you talking for week 2 or week 3? Because I don't have week 3. I'd have to text him real quick and have him email them to me, or you can type it in the chat. Is it week 2, Justin, or week 3? Week 2. Okay. So do you have a specific question in mind? Because that's what I was just working on, was the day 2 stuff. Some of it's a little wonky. I'm not real sure what they were asking for. I think it all comes down to either the first, like 8 through 14. I think they're true or false. Like, is this true or is this false type deal. And then 1 through 10 is just setting it up. You have example number 9. I just did example number 9, Justin. Oh, wait, number 9. Oh, I haven't done 9. Okay. Wow. Okay, so here we go. Arc sine of 5 pi over 3. And he says it's going to equal 5 pi over 3 minus 2 pi, which gives him negative pi over 3. Okay. So really? Sine of 5 pi over 3. What quadrant is that in? That's in quadrant 4, right? Right. Quadrant 4, 5 pi over 3. And that's going to give me 5 pi over 3 should give me negative root 2, nope, square root of 2, no, yeah, negative root 2 over 2. So I have arc sine of negative root 2 over 2. Serves me right. This should be 5 pi over 3 This is root 2 over 2, negative root 2 over 2. Sine is your y value. Boom. Now, arc sine of negative root 2 over 2, arc sine of, now this is interesting because you have this idea of cast. Cast means it's negative pi over 2, 0, pi over 2, and then this is pi. Sine, negative down here, your answer has to be between negative pi over 2 and 0. So it's got to be a negative number. So this is actually negative pi over 4. So then this, what he's saying is if you do negative pi over 4 minus 2 pi, that it should equal negative pi over 3. It's not going to. So negative pi over 4 minus, we'll get a common denominator. Let's just do 8. So it's going to be 8 pi over 4. This gives me a negative 9 pi over 4. These don't match. This is false. This is wrong. So yeah, I think he just wants true or false. Is this correct or not correct? This one, it's a domain question. Because on your gut instinct says, hey, these are undoing each other. It's 5 pi over 3, but you have to think of your range of answers when you do arc sine. It's going to be between negative pi over 2 and pi over 2. So you can't have 5 pi over 3 because it's outside. Why did I do pi over 4? What am I doing? 5 pi over 3 is negative. Hold on. 5 pi over 3 is not that. It is square root of 3 over 2 negative 1/2. This, so sine of 5 pi over 3, which is one of those 3's. Oh my God, I am rusty. All right, what's the point at the 3's? 1/2 root 3 over 2. Okay, we're in quadrant 4, so that's negative. So sine of 5 pi over 3 is negative root 3 over 2. That means my range is still from negative pi over 2 to pi over 2. That's just a unit circle mistake. So that means my answer is going to be negative pi over 6, and then negative pi over 6 minus 2 pi, which will give me negative pi over 6 minus 12 pi over 6, which gives me negative 13 pi over 6, which is not negative pi over 3. Same thing though, I see what he's doing. He's laying a trap for you. He wants you to say that sine and arc sine, they are inverses of each other, so it has to be 5 pi over 3, and if I subtract 2 pi from it, I'd get negative pi over 3. That's a trap. So you have to be careful because of your arc sine range, your output. Your domain is from negative 1 to 1, and your range is going to be from negative pi over 2 to pi over 2 because you have to cut it to make it a 1-to-1 function. So it's just a trap. It's a classic trap. Question Q4, question 4. I thought I just did 4. 5 and 13. That would be a 5, 12, 13 triangle. What do you mean by Q4? Yeah, quadrant 4. You're right. It has to be in quadrant 4. So I just made a unit circle mistake, but it's still the same trap because this is in quadrant 4, but your arc sine is going to be from negative pi over 2 to 0 in quadrant 4. It's the same type of trap that all pre-cal teachers have done. I've done it to my students in the past as well. That was just a unit circle mistake. Silly me. I know my unit circle. All right. Yeah, I figured that out with Q4 quadrant 4. Any other questions? Or I'm gonna shut it down, and then I'll be back up at 5. Been at this now for a pretty good amount of time. All right, guys, it's been an hour and a half. It's 6:35. If you have more questions, I'll be back up at 5 o'clock tomorrow. To answer your questions. I'm going to go ahead and get the pre-cal packet for this week, and I'll text the pre-cal teachers and ask exactly what they're looking for on week 2, because that's kind of, All right, so I'll be back up tomorrow at 5 o'clock. So if you have questions, just be back here again tomorrow. See y'all tomorrow at 5.